Hello students, welcome to Sarasa classes. Now the question here given is regarding crystal field theory, and the question says if the crystal field splitting energy of CONH3 whole 4 2 plus is 5900 centimeter inverse, which means the mu bar is over here 5900 centimeter inverse. All right. So if we convert that into meter inverse, it will be 5900 into 100 meter inverse. Then the magnitude of a CFEC in kilojoules per mole rounded off to 1 decimal place is what we have to find out. So over here the complex obviously is CONH3 whole 4 2 plus, so it is a tetrahedral complex. Alright, now oxidation state is 2, so obviously cobalt over here 2 means it is a D7 system. So in the tetrahedral field, what will be the arrangement of orbitals? So it is going to be E and then followed by T2. This energy over here is delta T. Alright, for the first energy level we have 0.4 delta T, that is the higher energy level, and for the lower energy level we have minus 0.6 delta T. If we fill up the electrons over here for the cobalt system, and as we know that delta T obviously is very less than that of the pairing energy, so this is going to be a high spin complex, so there is no doubt about that. So obviously if we fill up the electrons, so now this is the energy ordering, this is the electronic configuration we will get. So if we calculate the CFSE value, then that is going to be 0.6 delta T into 4 plus 0.4 delta T into 3, and that is going to be 1.2 delta T. Okay, that is going to be 1.2 delta T. All right, so now we're going to find out delta T. So to find out the delta T, all right, so we just need to consider this to be as in terms of energy. All right, so that is going to be hc, that is Planck's constant, into speed of light into nu bar, and because it is per mole, so it is going to be Na. And so according to the equation that we have now, we just need to plug in the values of the constants, which is going to be joule second into 3 into 10 to the power 8 meter second into 5900 meter second, all right, into 6.023 into 10 to the power 23, all right, so that becomes per mole. And since we are dividing this whole thing by 1000, because it is needed to be found out in kilojoules, we are in joules, so we have to divide by 1000. So that means now we can say, if we calculate this whole value, it will come out to be as 70.6378 kilojoules per mole. We just need to plug in this value of delta T over here, then we will get out the answer to be as 84.76 kilojoules per mole. So that is how we have to solve for this question. All right, and I hope that explains how this needs to be done. All right, for this molecule that has been given over here in question number 60, and that should be our last question for this solution of organic and inorganic part in the JAM 2021. Okay, so So that is what it is, has been given, and we have to find out the all possible stereoisomers, which means all possible means we have to find out for the OI and GI. Okay, both the optical isomers and the geometrical isomers. For that, what we need to first need to understand is that GI will be shown when suppose the groups across the double bond or a spido system or say for a biphenyl, okay, such as these, okay. So for a C double bond C system, that is an alkene system, here A can't be equal to C and B can't be equal to D. If that is the case, then it will not show GI. So as we can see for this particular carbon, there are two CH3 groups. So it means that here A is equal to or B is equal to D. So that means we will say this is this particular bond over here, okay, that we see. This is not going to show our GI. So if you identify the stereogenic centers, then we will say this is one stereogenic center. Over here, it is attached to OH, CH, and this whole group is different from this one. This total group on the right hand side is different from the group or alkene at the left hand side. So this is going to be our another stereogenic center showing optical isomerism, and this is going to be another stereogenic center. So there are three stereogenic centers. Okay, molecule is unsymmetrical. All right, the molecule over here is unsymmetrical. Okay, molecule here is unsymmetrical, so we will say it is 2 to the power n. That means 2 to the power 3, and our answer is going to be 8. So here the answer is going to be 8. That is the total count of geometrical and optical isomers that should be possible for this kind of molecule. Okay. Thanks for listening. Keep visiting our classes. Have a great day.